12th graders. Our second one for the afternoon is Stephen. He has done a great job he actually got way ahead early and told me, I think in the first semester, he's going to get his thesis paper done really early, and he did. He did a great job of it. Really impressed with his arguments, and so. And so,
I did. I can say them right now, though.
Hold on. Give me a second. So Stephen says, I would like to thank Mr. Wade for being a helpful rhetoric teacher and Mr. Christian for advising me throughout the creation of this thesis paper. Stephen's title is Calculators Don't Kill Math, Why AI Won't Kill Computer Science. All right, I'll get the timer set up and I'll tell you when you can start.
I was doing so much.
All right, you can start when ready.
What springs to mind when you're asked to think of an invention that revolutionized mankind? For some of us, a calculator might be the first thought. When the calculator was first released, it not only impressed people, but also did it scare them, and immensely at that. Mathematicians who took pride in their fast mental prowess had suddenly questioned their own necessity. Were they being replaced? But the calculator did not eventually kill math. It enhanced it in a way that we have never seen before. It allowed humans to focus on ideas and innovations, not simple arithmetic. Nowadays, AI is the new calculator. At MIT, Professor Eric Klopfer ran an experiment on his computer science class. He divided the class into 3 different groups and gave them all the same assignment, a task that had to be completed in Fortran, an old programming language which none of them knew. The first group was allowed to use ChatGPT, the second group was allowed to use Llama, but the third group was only allowed to use Google, the search engine. Expectedly, ChatGPT's team finished the quickest, and they were shortly followed by the team who had used Llama. Team Google had finished last. However, when they were told to solve the exact same problem by memory, every single team had failed, except the ones who had to use Google. They were the ones to actually figure things out, and they were the ones to pass with flying colors. Just like calculators, AI is a helpful tool, but can pose to be suboptimal if you rely on it blindly without knowing the underlying systems at hand. Now, before diving any deeper, let's take a moment to look at things historically. The idea of automation is nothing new. Talos was a figure in Greek mythology known for continuously throwing boulders at ships and invaders. Thousands of years later, scientists developed computers with the ability to repeat tasks and automate calculations at unprecedented levels of efficiency. The next giant leap was quite obvious for these genius scientists, to replicate human intelligence using these new giant calculators called computers. Now fast forward a few decades later, and computers have come quite close to what these genius scientists had initially envisioned. But they might have gone even further. Is a computer science degree itself even viable, considering how smart computers are? Well, a viable degree can be defined as a degree which meets a number of requirements. For one, it teaches students the fundamental theories which transcend the current technologies that exist in that particular field. It contains a high possibility of being transferable to other fields, and it also meets a certain and sufficient amount of demand, enough to get employed. Computer science is an example of a degree. Computer science, or CS for short, is the study of computation, information, and their application. A part of this degree happens to include artificial intelligence, or AI, which is the technology that allows computers and machines to simulate human intelligence. AI generally works through computers detecting patterns that arise in large data sets, and from there, it provides an output given a certain input, such as a prompt. As of late, AI systems found in chatbots such as ChatGPT and Gemini have garnered worldwide attention. Stemming from that attention, some have gone as far as to say that programming itself would become obsolete. The event that truly accentuated these anxieties was the release of Devin AI, a supposed AI software engineer which claimed to be a savant in development abilities. And people really got scared when Devon AI claim to be a software engineer. From this, it is logical to question whether a CS degree remains a viable option for university applicants, considering the recent uprising of AI. Now, for the past decade, a CS degree has been the go-to degree for university applicants. Most people often associate a CS degree with above-average salaries. So as a result, obtaining a CS degree, especially one from a high-end university, might seem like a golden ticket for your typical savvy 18-year-old. The issue of whether CS is a viable degree is extremely important for those who are interested in technology and are about to apply to university. Picking the wrong degree might lead into one wasting a lot of time, and more importantly, spending a significant amount of money on something that may not even benefit them in the future. Some say that AI will completely replace software engineering. That is, the primary sought-after job by CS graduates. Others say that it will merely help those who have a CS degree. All in all, there are many different ways that people have perceived the effects of AI in the CS field. But when we take everything into account, one stance stands out. Despite the current uprising of AI, computer science remains a viable degree for university applicants for 3 different reasons. For one, it contains foundational knowledge that still proves to be a necessity. It drives innovation in various different fields beyond just that of AIs, and it also fosters an ethical and responsible technological development. To start, CS as a degree is still important due to the necessity of a fundamental understanding of how computers work. First of all, AI-generated code still requires human touch, which relies on those foundational CS skills. Although AI is supposedly sufficient in the writing of code, it still fails miserably in terms of checking and fixing that code. And as such, anyone who decides to integrate AI-generated code into their work is advised to look before they leap. This is what Alex Gu, a PhD CS student over at MIT, emphasizes in his TED Talk and research paper. An iteration through writing, checking, and fixing that code is essential to building a piece of robust software. A symbiotic relationship between human developers and AI is much more likely to come for the next 5 years. Professor Simmons over at Carnegie Mellon seems to agree with Alex Gu. Simmons gives a handy analogy for this current landscape of CS. Teaching a 7-year-old arithmetic is still essential, although no one does arithmetic by hands once you get to middle school. Nowadays, everyone uses a calculator. Even if calculators do all the dirty work, we still need people who understand the underlying systems which are being taken place behind these fancy buttons and symbols. Next, CS degrees ensure a structured learning of fundamentals, which are not always easily accessible through self-study, including solely learning from AI. ABET, or the Accreditation Board for Engineering and Technology, is the primary accreditor for engineering and technology programs all across universities all across the world. In garnering their accreditation, one must have their students follow a set amount of criteria, such as having at least 30 semester credit hours of foundational and advanced computing topics that provide both breadth and depth. Now, universities that provide this range from MIT in the US all the way to ITB over here in Indonesia. Although not always required, an accredited bachelor's degree in CS would prepare someone for more advanced engineering roles. They provide certificates from reputable universities given by recognized individuals, and their programs cover fundamental CS topics, programming languages, software design methodologies, and a lot more. The last sub-reason comes from the fact that jobs will evolve, but skilled programmers will always remain in demand. Former Microsoft software engineer Dave Plummer, known for making the task manager in Windows, states that while programmers will always be in high demand to actually design, build, and deploy the AI systems themselves. And he states that as of now, we only have AI-assisted code, not fully fledged AI programmers that are able to build wide-scaled applications. And so CS involves tackling a unique problem that AI cannot autonomously solve. On a similar note, Young, a PhD student in neurology over at the University of Hong Kong, discovered that the incorporation of AI into healthcare actually requires the healthcare professionals to learn computer science skills. Only from this can they master AI programs in order to fully utilize their potential. However, simply enrolling in AI standalone courses isn't sufficient. Young suggests that AI education should start at the undergraduate level in healthcare education, so that there would be a coherency between the building of their AI knowledge and their medical knowledge. He basically states that AI simply replacing humans is just not feasible. My second reason as to why CS should remain a viable degree is due to it driving innovation in various different fields, even beyond just that of AIs. First off, CS programs actually teach problem-solving skills that are beyond rote coding tasks. The story I mentioned near the beginning proves to be an example of how working hard and struggling is actually an essential part of learning. When provided with an even more complex problem, it would be tedious to go all the way back to the beginning of an LLM, such as ChatGPT, and try to integrate a new feature or try to troubleshoot a new feature. The MIT professor who ran the experiment emphasizes that breaking down the problem, the larger problem, into smaller problems is a critical, if not essential, skill that a programmer must learn. Now, beyond this, Mr. DeVries of SourceGraph emphasizes on a distinct difference between two categories of programmers, the solution copiers and the problem solvers. The solution copiers tend to not care about how things work. Detrimentally, they create a solution for a problem that might be suboptimal. On the other hand, the problem solvers are the ones who actually understand the problem and who try to solve the problem via understanding. Well, obviously. This is the skill set which will remain useful for CS graduates even if they never manually write a single line of code again, ever in their lives. Next, and this is a very, very important one, AI lacks creativity and is thus unable to look forward. Dr. Charles Severance over at the University of Michigan says that AI has not been creative, is not creative, and will not be creative anytime soon. AI is great at looking at what humans have done in the past, is good at speeding up that process, but is unable to look forward and invent new things. It really can't anticipate what the next step is going to be, and thus it becomes futile in the face of an unsolved problem. Two different academic papers seem to agree with Dr. Charles, in that AI will never truly be creative, but would undoubtedly be very useful in completing various different tasks of varying complexities. One paper lists one of the criteria for authentic creativity as, and I quote, the ability to evaluate the usefulness of one's creation, which AI is currently unable to do. Innovation, by definition, requires creativity. In an ever-evolving tech world, innovators, especially those in CS, are completely essential. The last argument partly stems from the previous one, which is that CS plays a key role in the advancements of many different sectors, such as healthcare and history. From helping surgeons perform their tasks wirelessly, to allowing historians and archaeologists understand the Amazon rainforest to a degree that we have never seen before, technologies like software engineering, data analysis, and other disciplines in the CS field all contribute to these innovations. Those two examples are just 2 grains of sand in the never-ending beach of CS applications and innovations. The third and last reason why CS should remain a viable degree for university applicants is because CS fosters an ethical and responsible perspective for technological development. First of all, there is an algorithmic bias in artificially intelligent systems which must be brought to a minimum. Those biases stemming from large datasets can lead to unfair outcomes and even perpetuate existing inequalities, like the misrepresentation of individuals in synthetic data. In an effort to reduce said risks, universities provide CS courses which go over the identification and also the mitigation of how algorithms, data, and mathematics can play a role in the injustice of AI-generated responses. Harvard, Stanford, Georgia Tech provide such courses, just to name a few. Beyond that, these programs are also made to follow the criteria in garnering the ABET accreditation for an undergraduate computer science degree. One with this accreditation must have their course prepare their students to, and I quote, make informed judgments in computing practice, taking into account legal, ethical, DEI, and accessibility principles. As the advancements of AI technologies take place, new ethical challenges in the form of bias and hallucinations call for the increased attention in CS ethical education. Secondly, soft skills like communication, mentorship, teamwork, you name it, are essential and hard to replace by AI. Students from the University of the Middle East conducted a study which found out that while AI has forced a change in the practices of educational institutions, it was commonly established among scholars that soft skills are very important in education, which led to it being incredibly important in the workforce as well. And finally, human understanding is essential for meaningful software development. And this is extremely hard to replace by AI. According to Dave Plummer, a significant part of engineering consists of understanding human needs, behaviors, and preferences. AI lacks the innate human ability to immediately grasp these aspects, which are actually crucial for designing user-centered applications. Custom software development often requires a deep understanding of specific client requirements and context, which AI might not be able to understand on a human level yet, or might never will. AI in its current form is not adept at fully grasping and adapting to such varied and nuanced requirements. Now, similar to the previous take, Andrew Ng believes that AI is often lacking a lot of context about why we do certain things, while humans, on the other hand, have a lot of context. He gives a practical example of when he was in the process of creating an app, which he told AI to do, and it turned out to be really, really slow. So he decided to implement a caching system. You can think of a caching system as a way to obtain something in a quicker sense than you would usually get it. And so he tried to implement this caching system, but he had forgotten the syntax for the caching implementation. So he got the AI system to implement the caching implementation perfectly for him. This instance made him reflect that human context clues were actually able to come up with an abstract solution to a problem that AI had not initially given him. And so researchers from the University of Auckland also say the same thing. They emphasize that AI serves as a tool to enhance developers, not to completely replace them. Some might argue that there has been a massive amounts of layoff in the technology industry, where CS fresh grads are having a ridiculously hard time finding a job. Is this all because of AI? While it might look that way on first glance, other factors must not be overlooked, one of which are the interest rates. Cora Cantega, a head of economics at LinkedIn, one of the biggest job-seeking sites in the world, stated that the interest rates have been coming up while hiring has started to slow down. He continues by saying that this gradual slowdown has been happening since the spring of 2022. This data aligns perfectly with the tech opportunities drop. CS Dojo, a popular computer scientist completely separate from Mr. Cantega, appears to have come to similar conclusions with Mr. Cantega. He believes that there is a strong correlation between the two, namely the job opportunities and the interest rates. As Cantega puts it, it's certainly possible that AI could be playing a role in what's happening in the labor market, but I think it's too soon to make that call. Lastly, and the most compelling argument for the obsolescence of a CS degree would be that we will never really know when AGI would come into place and replace all CS majors. According to Amazon's website, Artificial General Intelligence, or AGI, is a field of theoretical AI research that attempts to create software with the ability to simulate human intelligence and the ability to self-teach. The aim is for the software to be able to perform tasks that is not necessarily trained for or developed for. But as of yet, humans have not been able to produce anything that resembles AGI systems. While the possibility of the production of AGI seems probable and also frightening, the fact of the matter is that the production of such a system is currently on the ongoing stage and is way ahead of the current era. Amazon states that achieving AGI requires a broader spectrum of technologies, data, and interconnectivity than what powers AI programs today. To recap, we've discussed the viability of a CS degree in the AI era which is currently taking place. First of all, CS degrees provide foundational, essential knowledge which still proves to be a necessity for university graduates. Secondly, CS drives innovation beyond just that of AIs in field. And lastly, CS fosters an ethical and responsible technological development. As citizens of a rapidly evolving world, it is of the utmost importance for us to equip ourselves with technological literacy and guide artificial intelligence using our inherent wisdom and responsibility. Proverbs 2 verse 6 states that, "For the Lord gives wisdom, from his mouth come knowledge and understanding." I believe that God has planted something within us, something that is beyond just that of mere logic. It is time for each of us to make a thought-out decision, one will have an immense impact on the next 4 years of our lives. As for computer science, it is beyond just that of a mere career decision. It is a commitment to utilize critical thinking skills and problem-solving skills in order to find solutions to complex problems. In this day and age, let us choose to build, not to fear. Let us innovate and not walk away. Thank you.
Good job, Stephen. Our panelists today are Mr. William, who serves as our computer science elective teacher, our programming elective teacher, and Mr. Tony. I'll let Mr. Tony go first. Okay, I'll let William go first.
Yeah, okay. Thank you, Stephen, for the speech. Maybe I just have one question about the job, about the occupations that related to the computer science. It's like application tester or software tester or find some bugs. I want to ask questions about how about this occupations, how about this job? Will it be changed or switched with the AI or how?
All right, thank you for the question. And so I actually mentioned it near the beginning of my arguments, where as of now, AI is pretty sufficient in the writing of code itself, but it's still, according to Alex Gu and researchers from NYU, Cornell, Harvard, and MIT, they all found out that the checking and fixing of code, or in the software world is called the testing of code as well, it still fails miserably. it fails miserably, and for that reason, I think that that's still a great place, like if you're going to take computer science, it's still a great place to find a job. And what I like to think of this as, one of the analogies I like to use is, if AI was able to create self-driving cars, if AI was able to create all the way from the manufacturing to the software testing to the driving of the car itself, would you trust that car? Like if you knew that no human was involved in the process of the production of that car, regardless of whether the computer scientist made the AI to make the car itself, if you're following what I'm going through here. And so, me personally, I would not trust a self-driving car which was made by AI. And so, I believe that's one of the great areas to dive into when you graduate as a CS student in 2025 and so on.
Yeah, okay, thank you. I think that's all for my questions.
Mr. Tony?
Yes, thank you. Well done, Stephen.
Thank you, sir.
I enjoy your reading your paper, and I enjoy your speech. So it's I believe you pour a lot of hours preparing.
Yeah, many thousands of hours.
Thousands, with AI or not. But your gesture, the way you deliver, I believe is one of the best that I watched until now. Yeah, so good job. Now, let me start with this one first. What is your intent? What your major that you are aiming for college?
So my intended major?
Yes.
For me personally, I don't know. But it's aiming to the area of technology and computers. So either computer science or some engineering role.
Okay.
That's me personally.
Yeah, for you personally. What do you think if someone asks you, since you researched this, what college major will have a biggest impact, get the biggest impact because of AI development?
All right. So I'd like to clarify on your question. You asked me about the biggest impact that AI would have in picking a degree for university applicants, right?
Yeah.
And so would you mean that impact to be detrimental or actually to help to bring it to another level?
Detrimental. Thank
Detrimental.
you. Thank you for asking.
Okay.
Clarify.
I'd say one of the quote unquote less don't pick this degree would be to be accounting or something in the economics field. But in my opinion, this is only because economics contains a lot of data sheets, Excel spreadsheets, and algorithms, which that's perfect for AI, right? If we think about how does AI work, it works on characters that computers can understand, like the Latin alphabet, for example, and it kind of fails in terms of art, designing, and stuff like that. And so I believe that anything related to linguistics even, maybe an English major, because ChatGPT, like it's very evident that it's a savant in terms of English. And I believe that anything regarding computers as well, so anything that to do with numbers, right? As Mr. William would know, he's a programming teacher. There's integers, booleans, all of these things are included in economics and accounting. And I believe that because there's so much data of that, it would also be one of the majors that might not be completely replaced, but have a significant amount of detrimental impact too.
That's good. So you mentioned a bit, because of the data that can be found is enormous, like so many. So the trained data can be used for AI. So AI really advanced in that area.
That's right.
Okay. And one of them is computer science, right?
Sure.
Just that you said. But you have done a very good research. Let me ask further. Have you tried to ask one of the GPT to solve problem?
Yes, a multitude of times.
Okay. How successful you find the AI can do that?
I love that question. Thank you for that question. So, actually, I happen to be coincidentally a hobbyist programmer, and in the production of my apps, I specifically dive into the world of Android, because Android is I don't know if you know this term, it's called open source, which means that there's a lot of research, there's a lot of Stack Overflow helping us. And in the creation of that Android app, I tried to make the AI like implement a feature for me. But one of the factors that we have to understand that AI works by seeing data, right? And if you're working with the bleeding edge technology, like Android app development, the one I use is Jetpack Compose, it's a very like niche topic, and it's a very niche subsection of programming, which there just isn't enough data to work with. And because of that, AI fails miserably in terms of creating Android apps. But I would assume, because there's so much code revolving around the production of websites, like HTML, JavaScript, and CSS, I believe that if you ask AI to create a website for you, it would be much more capable in doing so.
Okay, well done. So you not only know the theory, but also you try your application. Yeah, so since you have that information, I will not share my own story, but it's okay.
Go ahead, Mr. Out.
Yeah, no. I have more question. Next one is, because I've been reading this, and perhaps my phone listen to what I read, my discussion with my friend. YouTube fit me with a lot of things, especially like the advancement of AI. One of them is a talk between Mark Zuckerberg, the founder of Meta, and one other guy, CEO of, I believe, Microsoft. And this was posted about a month ago, asking how many % is the programming has been developed by AI. Do you know that?
I know exactly what you're talking about.
Okay. So can you say how
All right.
many % that has been
So-
not human made, but AI made?
All right, so you're asking about what percentage of the code was AI generated, right?
Yes.
And so, if I remember correctly, the Microsoft CEO said 30%.
Yes. And Meta says?
I'm not sure about Meta,
Okay.
but Microsoft's CEO said 30%, and can I dive deeper into that?
Yes.
All right, so the 30% that the Microsoft CEO stated was researched upon by programmers, and they found out that 29.999% of that was boilerplate code. So
Okay.
you can think of boilerplate code as like the template. Like you don't even have to use AI for that, but in a sense that AI could find the files and make the boilerplate code, it would be useful. But 30% of that was boilerplate code, which requires no logic. It requires no human understanding, it requires no human design, it requires no human creativity. It was just a production of that boilerplate code. And for that reason, I think that is quite a fallacy in terms of stating that 30% of that code was AI generated, because, as I just said, a lot of that code was boilerplate code.
Okay, well done. If you do the research, well done. Meta owner says that 50%
Again,
code has been replaced, not human made, but AI made. But yeah, you have the argument that very solid, and we know that up to now, even if we do our own application, simple tasks, sometimes AI still miss here and there, yeah?
exactly.
Okay, good. Let me add to another one. In the past, people always think artificial intelligence cannot beat humankind. Back then, chess is one of the benchmark. Now, Stockfish has like way beyond what Magnus Carlsen can do. Yeah. Do you think in the future AI can really good in whatever that we ask them?
All right, so you're basically asking, will AI be able to excel
Yes.
in any type of category that we throw at it?
Yes.
All right. So in order to answer that question, I love that you use the real-world analogy of chess,
Yeah.
because the way it went was AI sucked at chess, and then AI was pretty good with human help at chess, and now AI just excels at chess, right? And it completely destroys even the top grandmasters,
Yes.
even those people. And to answer the question whether AI can excel in every single category of life that we throw at it, I think it comes back to the main root, the main fundamentals of how AI works. AI works on data. So in any given category, if we have a good amount of data, and if we have this technology called reinforcement learning, if we give it a nice rubric for reinforcement learning, I believe that it will be able to excel in that field. And chess is a perfect example of that because there's so much data, and there's rules to chess, right? In programming, there's no rules, really. You can create an application with 10,000 lines of code that does the same thing that 5 lines of code does. So I believe that.
Yeah, yeah, well done to explain that. Now, since you said the data is not exist, and you said earlier, AI can generate things. So AI can generate data that it needs to learn, and then learn faster, learn better. What do you say about that?
I'm sorry, I really don't understand the question. Could you rephrase it?
So, you said that we need data to learn. Okay, we give just a bit of data.
Sure.
Let's say Android program.
Sure.
And AI can take it, create something from it. The result, the product can be fit into the system and make it better and better.
Ah, I see.
What do you say about that?
So this is a category of AI which I reference in my thesis here and even in my speech called artificial general intelligence, or the ability to self-teach, right? One of the
Yes.
components of AGI is the ability to self-teach, which AI in its current form is not able to do. Like ChatGPT and Llama and Gemini, they all work, they're large language models, they all work on pre-existing data from the internet. So they scrape all of the words from the internet and they feed it into this ChatGPT, and from there we can ask it and it'll spit out a response that is probably to our expectation. And so in terms of giving it data that it produces itself, it's like a never-ending loop of, it's a category of AI research which is beyond what we have right now. So if you were to ask me how long would it take for us to come to that AGI stage, I would say that even the top researchers in AI, Ilya Sutskever, Geoffrey Hinton, they don't even know.
Yeah.
So if they're not even able to know, I'm not sure that I'm able to give a valid response on that topic.
Very good, very good. The last thing that I would like to ask, have you ever, I believe you know about the experiment, let's say, an AI talk to another AI.
Yep.
And now we know that there are so many models of AI. Let's say one AI is best in doing one thing, either designing or whatever, accounting, whatever, and the other is really good software engineering, for example. And these two can talk. Do you think they can collaborate?
That's a very good question. And the stage that we're at right now, that is being researched very heavily. It's called multi-model, multi-agent AI systems. And this is one of the biggest threats that Eric Schmidt, one of the Google CEOs, former Google CEO, said that it is one of the scariest types of AI that could have a crazy impact on our society nowadays. And he referenced multi-agent and also text-to-action. So text-to-action is the idea where you give the model English and it would respond with Python. Or think of Python as the English for computers. So this is one of the scarier things about the AI development we have right now. And yes, it would be very, very detrimental. But again, like I said before, even Geoffrey Hinton, even Eric Schmidt, they do not know when AGI would fully come into place. And part of multi-agent AI happens to be AGI. And so if I don't know when AGI would come into place, therefore I do not know when multi-agent technologies would also take over the world and basically replace all of us, right, in a sense.
Okay, well done. Thank you.
Yeah, you did a great job, Stephen. You know, as you know, I've been in the software engineering world for a long time. In fact, I've probably spent almost 20 years as a software engineer and developer. And so I've got a lot of background. In fact, when you mentioned the old, and I think when you said it the first time you did your speech for me, you called it the old rusty programming
I
language.
deleted the rusty for you,
I
Mr.
noticed that. That was nice because that's what I learned to program on. It was
I'm sorry.
Fortran.
I
And so
apologize.
but it's interesting. I've watched the evolution of programming from learning machine code as a computer engineer to Fortran, which is like one level above that. And then third and fourth generation languages like C# and Visual Basic and on to even drag and drop style programming these days. But would you say that AI is really just sort of another level of abstraction? Because that's what these kind of different levels are, abstractions. Would you say it's just another level of abstraction for computer scientists to work with?
Thank you for that question, Mr. I believe you're the expert in this field of research right now. And if you're asking a high schooler like me, who only knows barely anything about the real world of programming, I would say that, yeah, you're completely right. So what we have nowadays is aiming towards prompt engineering. So prompt engineering is basically asking an LLM to produce this type of code, make this component, make it do this, blah, 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 and it will produce that and make it Python. And Python runs on C, and C talks to that machine code. And so we have these levels of abstraction that we work with in order to actually just simplify what we were trying to do in the first place.
Yeah, very good. It's I like your topic so much it's hard to argue with it, but I do think computer science, there may be a lot of computer scientists that lose their jobs with AI, but I honestly think, having experienced in my world, most of the computer programmers out there actually are the solution copiers. They're not the problem solvers. And I know firsthand as I went back to America from being here in 2010 and I got a job immediately, really rusty. How many times did I go to Stack Overflow, right, and copy a big chunk of code because the solution's right there? And what I find is that there's a lot of programmers out there who have learned already before AI to find solutions online. And so would you say that perhaps AI, this new wave of AI coming, is actually going to clean house a little bit and get rid of the solution copiers and really force companies to have real problem solvers?
So you actually asked me this question when I was first having a trial thesis with you. And one of the things that I found was that although there might be a motivation for solution copiers to now take further action with this new idea of prompt engineering, I still believe that, I'd argue that the reason you got hired in the first place was because you had some sort of engineering role, right? And you had this sort of credibility. One of the arguments that I stated here was that CS provides a structured learning for fundamentals, which is not easily accessible through self-study. And so since you have this credibility from reputable universities given by recognized individuals, that was the reason you landed the job. And whether you take the path of solution copying and in doing your job, I think it's more to how you landed the job in the first place. I think that's a more important issue in this question.
Okay, good. Let's see. Oh, we're almost out of time. Let me think of one more question real fast. Yeah, can you elaborate a little bit? And I think you've already sort of done this, but I'm going to have you ask you again. On this AI-human symbiosis, how do you see that happening and working sort of in a practical sense?
All right, so the basis, once you have someone who has a CS degree, is basically a CS graduate with the ABET accreditation, I believe that they have a fundamental understanding of how computers work, and from there, they only need to they can extract their knowledge and use prompt engineering in order to write what they want, right? So if you ask a non-programmer to build an application, they're going to be like, what? What do I do? What's the first step? And what's a programming language? What's a variable? What are all these data types? What am I working with here? So those who don't have a CS degree, they're blind to what the inner workings of a software program have. And the difference between the CS degree and these solo learners or even hobbyists would be that fundamental understanding. And so the symbiotic relationship would come into play there. So when you have a more advanced, like I mentioned here previously, a more advanced complex problem, you'd be able to solve the problem with ease. because you know the fundamentals which are able to be used in order to tackle that specific problem.
Yeah, good. So in the business I worked at, there were a lot of programmers or software engineers who had a lot of experience, sort of in their old age, went into something called maybe a solution analyst or a business analyst, where they knew both the business itself and what problems need to be solved, and the world of the software environment that they live in, and how they can do that with software. Is that the kind of thing you're talking about?
Yep, exactly.
Yeah, very good. Okay, time's up. You did a great job, Stephen. We will meet over here for photos with family and panelists and friends and advisors. And then in about 10 minutes or less, we'll start with Ryan.